Hello guys, a very good evening to all of you. Today we are going to be having our second lecture on ICSE class 9 rational irrational numbers. Yesterday we have done everything there is to know about the basic part, what is rational, what is irrational. So today, now in this lecture, we'll start off with the new concepts. What is the new concept? How to draw irrational numbers using a number line. Okay, we'll start off with root 2 and root 5. Okay, so we have already watched the video. If you want me to play the video again, let's first play the video of like how to plot irrational numbers on a number line. After seeing the video again that we have already watched in the last class, we'll be going on into the next portion. Okay, let's first watch the video and understand what that is. One second. Okay, first let us watch the video how to plot irrational numbers on a number line. Okay, so we'll be starting off our class by watching this video first. After that, we'll continue with the rest of the lecture. Okay, let's begin with our first video of the day. Okay, so we'll be starting.
How do we represent irrational numbers on a number line? Numbers like root 2, root 5, they are non-terminating and non-recurring. It means that we cannot calculate its numerical value and plot it. It's not difficult at all if you understand just one simple concept. Consider a right triangle OAB. Let these two sides be equal to 1. Since this is a right triangle, we can use the Pythagoras theorem. In this triangle, OB squared will equal OA squared plus AB squared. These two lengths equal 1, so we get the right hand side as 1 squared plus 1 squared, which equals 2. So OB will equal root 2. The hypotenuse will equal root 2. That's all you need to know to understand the plotting of irrational numbers on a number line. That's it. We found the length of an irrational number. The only thing we need to do now is plot this length on a number line. We will see that in the coming videos.
Okay, so we'll be utilizing one concept, that is Pythagoras theorem. In this particular concept, how to plot this on the number line, we'll be using what? Pythagoras theorem. First, let me give you a quick explanation of what Pythagoras theorem is all about. Okay, so for that we are heading straight back into this. I'm taking this particular paper. Let's go into our presentation. We are in slide number 37. Let's locate it and let's start. Okay, second. So Pythagoras theorem basically is what? So if I have a right angle triangle, in right angle triangle, let me name the right angle triangle ABC. Okay, so AB and BC, this intersects at an angle of 90 degree. Okay, so what the side opposite to 90 degree is always known as the hypotenuse. So this side AC is equal to what? The hypotenuse. Hypotenuse. This side BC is considered as the base and this side AB is considered as the perpendicular. Okay, so obviously we will be not writing this huge terms. We will write the first letter. For perpendicular we will be writing B, for base we will be writing B, and for hypotenuse we will be writing H. So what does Pythagoras theorem signify? It signifies that hypotenuse square is equal to perpendicular square plus basis square. Or in other words, we can write AC square is equal to AB square plus BC square. Okay, so we can write AC is equal to root over AB square plus BC square. Now let's put an example to it. If I write the perpendicular is 3 and the base is 4, so what will be the hypotenuse? Okay, so we know, like, let us first assume only the hypotenuse is 5. So let us first signify whether this is coming or not. Okay, so AC square is, where is 5? The AC square is going to be 25. So 25 is equal to AC square. Now let's find out what is going to be. So first let me write down the equation. AC square is equal to AB square plus BC square. We have found out for this. AC square is 25. Now let's find out for this. So AB is nothing but 3, right? So 3 square plus BC is nothing but 4. So 4 square is, okay, now 9 plus 16, which gives us 25. So LHS is equal to RHS. Thus, this three sides are what is known as a Pythagorean triplet. Okay, we'll be using this entire thing for calculation of root 2 on the number line, root 3 on number line, things like that. Okay, this is the basic of how will we plot root 2 and irrational numbers, others irrational numbers on a number line. Okay, as we have now stated this, let's draw how to locate root 2 on a number line. Okay. There is a video. Let's watch the video first. How to plot root 2 on the number line. Give this video a very special, like, use your full concentration to understand only this root 2. Everything will fall into place after understanding only one of the examples. Okay, let's begin.
Using the concept we saw in the previous video, let's see how we plot the length root 2 on a number line. So let's plot it on this number line. We need to make a right triangle with one unit as the base. Let OA be the base of that triangle. We also want its height to be 1 unit long. Let's draw the height AB like this. We just drew AB equal to 1 unit perpendicular to OA. Both these length equal 1 unit. Now all we have to do is join OB like this. Let's analyze the figure. We have OA equal to 1 unit and AB equal to 1 unit. Using the Pythagoras theorem, we have OB squared equal to OA squared plus AB squared. That would equal 1 squared plus 1 squared, which is 2. Taking the square root on both sides, we get OB equal to root 2 units. This length here will be root 2 units. We just need this length here on the number line. To do that, we keep the vertex of the compass here and with length OB cut an arc on the number line. Let's call this point C. This green length OC will equal this length since they are the radii of the same circle. Hence length OC is also equal to root 2. And if we need minus root 2, then we cut the same arc on the other side of O. Let's quickly see how we can actually construct it. Let OA be 1 unit long. Then we take a protractor, make a 90-degree mark and join that point to A. Then on the compass, we take the length of 1 unit and mark it on this line to get AB as 1 unit. And then we join OB. This length OB is root 2 units. And that is the length we need on the number line. So we keep the compass on point O, take length OB and cut an arc like this. That gives us length OC as root 2 units.
Okay, so wasn't this very easy to understand? Wasn't this value very easy to understand? Let's continue with our class. Present. Present from beginning. I don't want to present from beginning. Okay, let's present. Now it's our time to understand how to locate root 3 on a number line. I think there is a video of this as well. So before further ado, we'll be seeing the video again. Okay, so we have understood how to plot root 2 on a number line. If you have not still understood how to plot root 2 on a number line using Pythagoras theorem, we'll be watching one more video how to understand and plot root 3. Okay, chalo, let's give this a watch.
Let this be a number line with the same unit length we saw in our previous video. We had got the length OC as root 2 units, so this green length is root 2 units. Now let's draw CD perpendicular to OC, where length CD is 1 unit. Let's join OD. This length is root 2, this length is 1. What do you think is this length? Let's calculate it. This is a right angle triangle. By the Pythagoras theorem, OD squared will equal OC squared plus CD squared. Length OC is root 2 and length CD is 1 unit. So OC squared will equal root 2 whole square and CD squared will equal 1 squared. That will equal 2 plus 1, which is 3. If we get the square root on both sides, we will get OD will equal root 3 units. This length is root 3 units. Look at the figure carefully. We have root 3 here. Can we plot root 3 and minus root 3 on the number line? Yes. We keep the vertex of the compass on point O, set it to length OD, and draw a semicircle like this. Let it intersect the number line at points E and F. OE will equal root 3 units and OF will equal minus root 3. So if we are able to plot root 2, we can easily plot root 3 by the same procedure. Construct a triangle with this length equal to 1 unit and base as root 2 units. Let's quickly see how it's actually constructed. We have OC, which is root 2 units long, and this length from C is 1 unit. Note that this is not 0. 1, 2. This length is root 2 and this length is 1 unit away from point C. We take a protractor, keep the center on point C and make a 90-degree mark. Then we draw a line through that mark to point C. We take the 1 unit length and mark CD on the line. To form the right angle triangle, we join OD. This length OD will be root 3 units. To get root 3 on the number line, we keep the compass on point O, select length OD, and cut an arc on the number line at point E. Length OE will be root 3 units.
Okay, so we have learned about how to plot root 2, how to plot root 3. Okay, now comes root 5. So just I'm gonna say one thing to you. We have understood what is the basic. First of drawing root 2, what did we do? 1 centimeter, 1 centimeter. So 1 plus 1 is 2. Hypotenuse is what? 1 square plus 1 square is 2. Root over 2, we are giving 2 square. Similarly, 3, we are using what? Root 2 and 1. For 5, we'll be using what? Let me just show you the diagram first before watching the video. Okay, 1 second. Okay. Now let's annotate this. See, we will have to find what is root 5. We know we can say as a fact that root 5 is nothing but 1 root 2 square plus root 1 square, then root of that. This can be one of the options, but also we could say something like this, that root 5 is root 4 plus root 1. But it is coming what? 2 plus 1, that is 3, which is not equal to root 5. Okay. So, in this particular concept, we have understood two things. One, what is C? Again, I am repeating myself. So, this is 0, this is 1, and this is 2. I am drawing a point from 1 to 2. Okay, let me give it with a new line. This is one unit. I'm drawing a perpendicular line of 1 unit as well. Now I'm going to add these two lines. This is 90. This will be what? 1 plus 1 root, that is root 2. From here, if I draw an arc, we are getting this value as root 2. Okay. Now for root 3, what shall we do? 1 second. Now for root 3, we'll be drawing a line again. This is 0. Let this till this line be root 2. Okay. This root 2 is the same as this root 2. Then I'm drawing 1 unit ka perpendicular line here. Then I'm drawing the hypotenuse. This will be what? This will be root 2 square plus 1 square ka root. So that will give us what? That will give us 2 plus 1 root, that is root 3, which is this root 3. Now same arc from here, cut it, we are getting the value of root 3. Okay. So we have understood how to draw root 2, and using root 2 we have understood how to draw root 3. Now it's time for root 5. Okay, let's go straight into the video and watch how to understand root 5. See, root 5 is divided into part 1, part 2. I'll be showing both of the parts, okay, one after the other. Let's begin.
In the previous video, we plotted root 3 and minus root 3 on the number line. In this video, let's see how we can plot root 5. The concept remains the same. We draw a right angle triangle OAB. This time, let OA equal 2 units and let AB equal 1 unit. By the Pythagoras theorem, OB squared equals OA squared plus AB squared. That equals 2 squared plus 1 squared. That gives us 4 plus 1, which equals 5. Hence, OB will equal root 5 units. This length OB will be root 5 units. All we have to do is get this length on the number line. It means we have 2 units as the base on the number line, and we draw this perpendicular of 1 unit to form a triangle. We see that in the next video.
Okay, so we've understood the part 1 of this, how to plot root 5. Now it's time for part 2. Let's give it a watch.
So let's draw a number line up to 3 units. Let OA be equal to 2 units. Let this length be OA. Let AB be equal to 1 unit and let it be perpendicular to OA, like this. To complete the triangle, we join OB like this. Now we have triangle OAB, which is a right angle triangle. This length is 2 units and this length is 1 unit. Using the Pythagoras theorem, we can find this length. We can say that OB squared equals 2 squared plus 1 squared, which equals 5 units. Taking the square root on both sides, we get OB equals root 5 units. This length equals root 5 units. But we need this root 5 on the number line. To get root 5 on the number line, we should keep the compass on point O, set it to length OB, and cut an arc like this, which meets the number line at point C. Since they are the radii of the same circle, OC will also equal root 5 units. This was very simple. We took the base as 2 units, the height as 1 unit, and transposed the hypotenuse onto the number line to get root 5 units.
Sorry, guys. Okay, so we have understood this part 1 and part 2. Now, after this, so exactly we have understood how. Even if you have not understood till now, let me again explain this to you in this particular portion. So, take a number line, draw a number line, and let's mark it 0, 1 centimeter, and 2 centimeter. Okay, so I'll draw this line from 0 to 2 centimeter. This, okay. Now this is what, this is 2 centimeter or 2 units, whatever we want to call it. Now draw a straight line of what, 1 unit here, which is perpendicular to the 2 unit. Now draw a hypotenuse. What is the hypotenuse going to be? 2 square plus 1 square ka root. Okay, so what is 2 square ka 1? 2 square is 4 plus 1 under root. This is root 5. So we have understood that this hypotenuse is equal to root 5. Same thing, cut the arc. Now this entire thing is now root 5. Okay, chalo. Now let's explain next one. First, let's see there is a video on this or not. No, there is no video regarding that. So let's go straight to the explanation. See, how do you plot root 6 and root 7 on a number line? See, root 6. First, let's start off with root 6. Okay, so in root 6, what can we see here? Or give your attention to this first. This. Okay, so we have already realized how to draw root 5 in a number line. So first, we'll draw a number line, and by the methods that was previously discussed, we're going to find out this length is root 5. So this length is root 5. Same 1 unit line here, hypotenuse here. So root 5 whole square plus 1 whole square ka whole root. Okay, let me change the color of the pen. So it will give us what? Root over 5 plus 1, that is root 6, which is the required answer. So we have found root 6 as this. So cut the line. This entire thing now is root 6. Now in order to find root 7, we have to utilize this root 6 first. Root 6 plus 1, same step. Root 6 plus 1, 7. 7, then this. So root 6 now. This is root 6. So again a straight line of 1 unit here. Again a hypotenuse here. This will be 7 root. Simply again an arc is cut. That will give us root 7. Okay, isn't that easy? Now next thing. Now we have to prove of irrationality of 2, 3 and 5. Root 2, root 3. We all know that these are going to be irrational. Why these numbers are irrational? Because if we solve this, root 2, root 3, root 5, they will be having non-terminating, non-recurring decimals. Okay, non-terminating, non-recurring. Because what is meaning of non-terminating? It will not be completed. Point 4, 1, 2, 2, 3, 4, 5, 7, 9. It will be like that, non-terminating, non-repeating. So we cannot say 1, 4, 1 के बाद फिर से 1, 4, 1 आएगा. No. 1, 4, 2, 3, 2, 7, 2, 9, whatever. It will be different number with no particular set of numbers repeating. So non-terminating and non-repeating. Okay. So let's see. I think there's a video on regarding that, proving irrationality. What are irrational numbers? How do you prove the existence of irrational number? Okay. First, let us understand this. So we'll be using what this was already done. Okay. This is we are using long division method. Okay. So as you can clearly see, it is coming 1.412135. It will keep on going as it is a non-repeating, non-recurring representation. Okay. So after solving this, see, you do not have to solve till this step. Okay, till here is also fine. If we even find out till here now, that is absolutely fine. Okay, we don't have to waste time. Okay, simply now for this second one, prove root 3 and root 5, same step, long division method of finding the square root of a number. We're going to be doing that only. Okay, solve like this again. Okay, okay, that is it. Or there is an alternate method that is even more interesting. Let us go into that alternate method. This one, what is given here? Let root 3 be a rational number. We are not telling it's a rational number right now. Let root 3 be a rational number. Root 3, if it's a rational number, if root 3 is a rational number, it has to be divided by a by b, where a and b are integers and b is not equal to 0. Right? Not equal to 0, but this is not going to work anyway, because we cannot even write this in a by b where we are getting two integers. Okay, this will only be possible when there is terminating decimals. Okay, sure. See, this is the rest of the portion. Let us get to the bottom of this. What is this happening? One second, let me clear this so that I can give a full screen approach. See, we have understood what the first step was. Root 3 is equal to a by b. After squaring both sides, we are getting 3 is equal to a square by b square. So a square is equal to 3b square. So a square is divisible by 3, and so a is also divisible by 3. So what is this? What is this statement? Okay. So I'm doing this again. Okay. Squaring both sides, 3 is equal to a square by b square. So a square is equal to 3b square. So this particular statement means a square is a multiple of both 3 and b square. That is what is written here. Okay. So a square is divisible by 3. So a is also divisible by 3. No problem in understanding that. Now let a, this portion, let a is equal to 3c. Now why did we take another value c? Because we want to compare it with the last value. So a square is equal to 3b square from here. Now in the like if we are taking this term and we are squaring this term, we are getting a square is equal to 9c square. So we are putting this 9c square here. So 9c square is equal to 3b square. So b square is equal to what? 3c square. Now b square is divisible by 3 and so b is divisible by 3. Same approach for the last step. Okay, so a is divisible by 3, b is also divisible by 3, but that is not even possible. So a by b is not rational, so root 3 is not rational, thus root 3 is irrational. Same thing for root 5. A square by b square, squaring both sides, a square is equal to b square, so a is equal to 5c, a square is equal to 5b square, so a square is equal to 25c square from this step. So we are substituting the value of a square here with 25c square. 25c square is equal to 5b square. B square is equal to 5c square, as both are divisible, like both cannot be divisible by b square and a square. So a by b is not rational, thus root 5 is an irrational number. Okay, I'll play another video regarding this again. Okay, one second. Okay. See, identify whether the following is a rational number or irrational number. Okay. First, let us assume this. This is one of the most important sums that will come. Okay. Let's see if we have a video regarding this. Irrational numbers. What do we need? Just this is rationalization. Okay. This will come next. Hmm, see, just watch this video first. Okay, this we have already done in the last class, but still, if you understood this portion, you will understand every sum that are going to come. Let's give it a watch again.
To prove the existence of irrational numbers, a right angle triangle ABC was considered. The triangle was such that these two sides equal 1, and the length of the hypotenuse was supposed to be found out. The Pythagoras theorem was used to get AC squared equals AB squared plus BC squared. AB and BC both equal 1. Substituting those values here, we got AC squared as 1 squared plus 1 squared, which equals 2. If AC squared is 2, AC will equal square root of 2. And Hippasus said that this is an irrational number. But why? How did he prove it? He used an indirect proof, and this is how he went about it. He said, let root 2 be a rational number. It implies that root 2 can be written as p by q, where p and q are integers which do not have a common factor. P by q is in its simplest form. How do we eliminate the radical now? To eliminate the root sign, we square both sides. So 2 equals p squared by q squared. Transposing q squared to the other side, we got p squared equal to 2q squared. This gives us a very important result, and let's call it our first equation. What does this tell us? We know that 2 multiplied by anything is even. So the first equation tells us that p squared is even. It also means that p is even. That's because if the square of a number is even, the number has to be even. 2 squared is 4, 6 squared is 36. If the square is even, the number is also even. So let p be equal to 2a. An even number is always in the form 2 multiplied by something. Substituting this value of p in equation 1, we get 2a the whole square equals 2 multiplied by q squared. A can be any constant. Opening the brackets, we get 4a squared equals 2q squared. Cancelling out the common factors, we get q squared equals 2a squared. Observe the right hand side. It's 2 multiplied by something, which means that q squared is also even, which means that q is also even. Wait, this gives us an interesting result. It tells us that p and q are both even numbers. This simply means that 2 is a common factor of p and q. If both are even, they will surely have 2 as their common factor. But look at what we assumed. We assumed that p and q have no common factors. So this is a contradiction to our hypothesis. Hence, root 2 is not rational, and numbers which are not rational are called irrational numbers. We can say that root 2 is an irrational number and cannot be expressed as p by q.
Okay, now as we have understood this particular concept, let's continue with our class. So identify whether the following is a rational or irrational number. Okay, let's see what is this all about. Okay, so see, first you will be given a number. You will be given what? A number. The number here is what? 3 root 2 into root 8. Without seeing whatever that is, first thing that I should be having is that can we like make 8 a factor of something? I know it's a factor of 2. So we are writing 8 is equal to 2 into 2 into 2. This can be written in case of 8, right? So 3 root 2 into root 2 into 2 into 2. Okay, now here root 2 into 2 roots will come outside, so 2 root 2. Okay, now see, root 2 and root 2 are the same, so we are taking root 2 common. Okay, so root 2 into root 2 into 3 into 2. Okay, so root 2 into root 2 is 2 into 6, giving us the answer is 12, which is a rational number, not an irrational number. Okay, next insert a rational number and irrational number between 3 and 4. Okay, now let's see. If a and b are two positive numbers such that ab is not a perfect square, rational number between a and b is a plus b by 2. That average thing, rational number, how to input that rational number, we all know. Even if we do not know, let me give you an example. Okay, see, I'm taking one number as half, another number is 3 by 4. Okay, I want to input one rational number between them. Rational number. What I will do, add the numerators, so 1 plus 3, add the denominators, 2 plus 4. So we are getting what? 4 by 6, that is 2 by 3. So that is a rational number between half and 3 by 4. Now in case of irrational number, what we will do? We'll be doing, this is for rational number, what we have done. In irrational number, we're doing half into 3 by 4, entire thing in root. So 3 into 8 root, or we can say what? We can say root 3 divided by 2 root 2. That is also the answer for imparting an irrational number between two numbers. Okay, did you understand? Let's move forward. Okay, next examine each of the following as a rational or irrational number. Okay, see, first thing, first question that we have is 3 plus root 2 whole square. One second, 3 plus root 2 whole square. 3 plus root 2 whole square, this we are putting as a plus b whole square wala formula. We all know it is going to be a square plus b square plus 2ab. Okay, now substitute the value as a is nothing but 3 and b is nothing but root 2. Okay, so we are getting, now let's just substitute the value. Here a is 3 square, b is root 2 whole square, and 2 into 3 into root 2. Okay, so we are getting 6, sorry, 9. 3 square is 9, 9 plus 2 plus 6 root 2, so 11 plus 6 root 2. Okay, so even if we solve this, we have got root 2 as one of the answers. So root 2 is obviously an irrational number, so this entire thing is going to be an irrational number anyways. So this is irrational, so this is an irrational number. Now for the second one, what is the second one? Root 3, 3 plus root 3 into 3 minus root 3. It is following what? The concept of a plus b into a minus b, and we know that formula is equal to a square minus b square. Okay, so what was a here? 3. So 3 square is 9 minus b was root 3. Root 3 whole square is 3. Plus answer is 6, which is a rational number. Okay, okay, did you understand? Now for the last one, 6 by root 3. Okay, so 6 by root 3, what will I do? I need to first eliminate all the irrational numbers in a denominator. So I'm dividing root 3 here and multiplying root 3 in the numerator. So I'm getting 6 root 3 divided by 3, that is coming out to be 2 root 3, which is again irrational in nature. Okay, I hope this is absolutely clear. Now choose two rational numbers and two irrational numbers between root 3 and root 7. Let's do this. So root 3 square is 3, root 7 square is 7. So choose any two rational numbers between 3 and 7, and which will give us a perfect square. See, this kind of questions are very self-explanatory. You just read this, you'll understand. You will have a very good concept of what we are finding out. Okay, nothing else we have to do. Just read this, you'll be finding out everything that is to be done. Second. Mm. Now we have understanding surds. Okay. Now we have a video regarding surds, addition and subtraction of real numbers. Sorry, this is the wrong video. Let's head into straight into the videos section only. Okay. Rationalization of surds and understanding surds. Surds and rationalization. What is rationalization of denominator? Okay, let's go this. Okay. See, before starting with rationalization of surds, let me make you understand what is surds. Surds is, this is also a surd. This is a surd. This is a surds. This is a surd. Everything here is a surd. Now, what is this? Surd is a set of number or numbers which will at the end be rational in nature. That's it. We have to rationalize this. And rationalization is what we have already done. What is rationalization? 1 by root 2. When we want to get rid of any irrational number from the denominator, we are going to rationalize this term. So 1 by root 2 into root 2, and in the numerator again a root 2. So we are going to get root 2 by 2. That is how to rationalize surds. Okay, that's it. Now let's watch the video and have a good understanding of what this is all about.
Look at this number, 1 by root 2. Before we consider the number as a whole, let's look at the numerator and the denominator separately. The numerator is an integer, or maybe you can classify it as a rational number, and the denominator is irrational. Remember, the square root of any number which is not a perfect square is irrational. In mathematics, we generally do not leave the denominator of a number irrational. We make sure that it is rational since the standard form requires us to keep it rational. But what about such numbers? How do we make the denominator rational? It's simple. This can also be written as 1 by root 2 multiplied by root 2 divided by root 2. In effect, we are multiplying this expression with 1 since this equals 1. 1 multiplied by root 2 will give us root 2 in the numerator, and root 2 multiplied by root 2 gives us 2 in the denominator. This expression is equivalent to this one, but we have made the denominator rational. This is the standard form. Doesn't matter what the numerator is, the denominator has to be rational. This process of making the denominator rational is called rationalization. So why do we need this? Why can't we just leave it as 1 by root 2? Well, there is no definite answer to that. It is the standard form accepted all over and we follow it. But one practical reason would be that it is easier to divide root 2 by 2 than it is to divide 1 by root 2. Think about it. What would you prefer to solve? 1 by 1.4142 or 1.4142 divided by 2? We used one number to rationalize the denominator. Square root of 2. What is this number called? It's called the rationalizing factor of the denominator. So we say that root 2 is the rationalizing factor of root 2. We will cover the topic of rationalizing factors in the next part of this video.
Wasn't that the same exact thing that we just did? Okay, so we have understood what is how to rationalize denominator. Then what is rationalizing factor or conjugate? This term conjugate is not a very difficult thing to understand, but let's give it a watch. Okay, conjugate is when we have more than 2 plus root 3, like that. Okay.
What's a rationalizing factor? In the previous video, we used the rationalizing factor to make an irrational denominator rational. Consider an irrational number like 7 root 3. How do we find the rationalizing factor of this irrational number? Let's understand the concept of a rationalizing factor first. We just have to ask ourselves one question. 7 root 3 multiplied by what number gives us a rational number? This number here will be the rationalizing factor of 7 root 3. Let's try multiplying 7 root 3 with root 3. Root 3 multiplied by root 3 equals 3. So this expression will equal 7 multiplied by 3, which equals 21. Yes, 21 is a rational number. We multiplied a number with root 3 to get a rational number. So we can say that root 3 is the rationalizing factor of 7 root 3. Now here's something interesting. Think about it. Root 3 is an irrational number, and if we could have multiplied root 3 with 7 root 3, we would still get 21. Root 3 when multiplied with 7 root 3 gives us a rational number. So can we say that 7 root 3 is a rationalizing factor of root 3? Yes, of course we can. 7 root 3 is a rationalizing factor of root 3. A rationalizing factor is sometimes also called a conjugate. So both these numbers here are rationalizing factors or conjugates of each other. Is the rationalizing factor of a number unique? Is root 3 the only rationalizing factor of 7 root 3? Let's try multiplying 7 root 3 with 2 root 3. 7 multiplied by 2 is 14 and root 3 multiplied by root 3 equals 3. This will equal 14 multiplied by 3, which equals 42. 42 is a rational number. So we can say that 2 root 3 is indeed a rationalizing factor of 7 root 3. We have found two rationalizing factors of 7 root 3, which proves that a rationalizing factor of a number is not unique. Now let's try multiplying 7 root 3 with 3 root 3. 7 multiplied by 3 is 21 and root 3 multiplied by root 3 equals 3. Hence this will equal 21 multiplied by 3, which equals 63. And 63 is also a rational number. So 3 root 3 is also a rationalizing factor of 7 root 3. Yes, it means that an irrational number has infinite rationalizing factors. So we can say that root 3 is the lowest positive rationalizing factor of 7 root 3. If we have 7 root 3 in the denominator, we can use any of these numbers to rationalize it, but it is recommended that we take the lowest positive one. It's pretty simple to find the rationalizing factors of such numbers. We just have to make sure that we get a rational number as the product. But what if the number is like root 3 plus root 7? What if we had this in the denominator? How can we rationalize this expression? We will see that in the next part of this video.
Okay. In this particular type of sum, what is written here, let me just start solving via this only. Okay. How do we rationalize if something like this is here? Okay. So first I will do what? I'll be solving both. When root 3 plus root 7 is in a denominator and when root 3 plus root 7 is in the numerator. Okay. If it's in a denominator, what we'll do, we'll start rationalizing. First, we'll always give priority to the one that has more size. Okay, the bigger number. So root 7 plus root 3 is the same, right? So in the denominator, I am multiplying with what? Root 7 minus root 3. So similarly, in the numerator, I have to also write root 7 minus root 3. So this will come out to give what? Root 7 minus root 3 divided by a plus b, a minus b. So 7 minus 3, that will give us root 7 minus root 3 divided by 3. This is 4. Okay. But if it is something like this, then we have to do what? Same thing. So First, I will convert this into root 7 plus root 3. Then multiply in the numerator by root 7 minus root 3. Similarly, denominator it will come root 7 minus root 3. Okay. So in the numerator it will come 4. In the denominator it will come root 7 minus root 3. So see one fantastic thing. If this is present in denominator, we are getting the negative portion in the numerator and 4. But if it's present in numerator, we are getting the exact reciprocal of what we have found out, right? Okay. So this is how we are going to solve all the sums. Chalo. Now is it okay? Let's continue. Rationalization of stars we have understood. Next rationalization in the denominator we have understood. This is done. This is also done. So before starting off with any doubts and anything, we'll have one more thing. How to rationalize irrational number two terms. Okay. So the thing that I have like made you understand, there is a video on it. First we'll watch the video and then we'll be focusing on the end of the session. This is the last video of the day, guys. Okay, give it a good watch.
How do we rationalize something like root 3 plus root 7? This is actually a sum of two irrational numbers. What do we multiply this with to get a rational number? Let me give you a hint. A plus b multiplied by a minus b equals a squared minus b squared. This is one of the most important identities we will use in rationalization. So what do we multiply this with? Let's try multiplying root 3 plus root 7 with root 3 minus root 7. Using this identity, we can say that this equals root 3 squared minus root 7 squared. Root 3 squared equals 3 and root 7 squared equals 7. Hence, this equals 3 minus 7, which equals minus 4. And minus 4 is a rational number. We multiply this with root 3 minus root 7 to get a rational number. Hence, we can say that root 3 minus root 7 is a rationalizing factor of root 3 plus root 7. It can also be called the conjugate of root 3 plus root 7. All we did to get the conjugate is change the sign in between. We just made this plus sign a minus sign to get the conjugate. Let's look at a couple of examples in which we need to rationalize the denominator. Here's the first example, 3 by root 5. The denominator root 5 is irrational, and to get this in the standard form, we need to make the denominator rational. We can write this as 3 by root 5 multiplied by root 5 divided by root 5. We are effectively multiplying this by 1. 3 multiplied by root 5 equals 3 root 5, and root 5 multiplied by root 5 equals 5. This makes the denominator rational. Remember, by rationalizing the denominator, we're not changing the value of the original expression. This is equivalent to this. Just like the denominator here is rational, and we did this just to get it in the standard form. The second example asks us to rationalize the denominator of 4 divided by root 7 plus root 2. To rationalize the denominator, all we have to do is change the sign in between. The sign here is plus, so the rationalizing factor of the denominator will be root 7 minus root 2. We write this expression as 4 divided by root 7 plus root 2 multiplied by root 7 minus root 2 divided by root 7 minus root 2. The numerator will equal 4 multiplied by root 7 minus root 2. The denominator is in the form a plus b multiplied by a minus b, which equals a squared minus b squared. Using this identity, we can write the denominator as root 7 squared minus root 2 squared. That equals 7 minus 2. 7 minus 2 is 5, and we get our expression as 4 multiplied by root 7 minus root 2 divided by 5. That's it. We got what we wanted. The denominator is rational now. Now let's look at the last example. 6 divided by 5 minus root 3. This example is slightly different from this one. In the previous example, both the numbers in the denominator had a radical, while in this example, only one number has a radical. But this denominator too is irrational. What do we do now? Do we just change the sign in between? Just like we did in the previous example? Yes, we can write this as 6 by 5 minus root 3 multiplied by 5 plus root 3 divided by 5 plus root 3. The numerator will equal the product of these two terms, 6 multiplied by 5 plus root 3, and the denominator will equal 5 squared minus root 3 squared, which equals 25 minus 3. And we can write this as 6 multiplied by 5 plus root 3 divided by 22. Simplifying it further, we can write it as 3 by 11 multiplied by 5 plus root 3. Since 11 is a rational number, we can say that we have successfully got the original number in standard form. Remember, whenever we have two terms like this which form an irrational number, just change the sign in between them to get the rationalizing factor. Plus will become minus and minus will become plus.
Okay, guys. So we have understood the entirety of the chapter now. We have know how to calculate irrational numbers in the number line, how to draw it using Pythagoras theorem, root 2, root 3, root 5, root 6, root 7, everything. Okay, we have finally understood what is surds, what is conjugate, how to provide it into a standard form, everything. So if you need any help regarding any sum or any particular topic or chapter, please let us know. Okay, until then, have a great day. See you soon in the next video. Bye bye.